our NXCAM webinar series. This is the episode 1, and the focus today is on programming automation. So I will just start introducing our today's presenters. So we have Joe Taylor. He's a UK pre-sales consultant for NXCAM and additive manufacturing. We also have Steph Veroso, who is part of the EMEA Pre-Sales Center of Excellence team, and he also has a focus on NXCAM and additive manufacturing. And then it's myself. I'm part of the EMEA portfolio development team with a focus on part manufacturing. So we'll display this slide at the end should you wish to get in touch with any of us. So to start with, I just wanted to get you familiarized with these webinar objectives and the ones to come. So a few years ago, we were running regular full-day technical sessions on NXCAM, and this was happening on a quarterly basis. And the last one was back in March 2020, just before the lockdown. So we're now reintroducing these activities under a digital format. They will be taking place, like I've already said, on a regular basis. And as we respect your time, we have decided to make these sessions not longer than 30 minutes. We know how difficult it is for you to get out of your daily jobs and concentrate on calls these days. Also, for additional flexibility, we are running for these webinars sessions on both morning and afternoon, and we will make a playback available to those who have registered but were unable to attend. So each session will have a focus on a specific part manufacturing topic. The sessions are supported by Siemens experts, and the goal is to share recommended best practices. You'll also have the opportunity to provide feedback on would-be topics when completing the short feedback survey form, which I'll give you more details towards the end. So let's start with today's topics on, again, programming automation. We'll be covering feature-based machining and the ability to recognize machining features on a part model. We'll be looking at an NX model and read product and manufacturing information, also known as PMI, added by the designer as a 3D model annotation. This is also valid for important models. So we're not just fixed on NX. We can import any third-party data formats. We then show you and explain how to best capture information, which could be surface finish, dimensional and positioning tolerances, etc., as data that will affect the selection of the machining processes and tools. So, for example, a different level of tolerance can trigger and will trigger the selection of a different machining method with extra operations. It's important to emphasize that with the Siemens NX technology, we do follow what we call a model-based definition process, which is simply the practice of producing a complete digital definition of a product within a 3D model. And this includes, of course, the geometry, PMI, and other metadata to be consumed by downstream manufacturing processes across the company. So with that, I would like now to hand over to Steph and Joe for the technical presentations.
Okay, so switching over to a different computer. So good afternoon all, and thank you, Pedro. So let me start by showing first the results of the automation I did on this let's so-called test part. And you see I have a mold here with different sliders, so different dimensions of the slider, so the width and the depth, So it's a slider open pockets and closed pockets with some holes in there. So you see M5 holes, M6 holes. No operations defined yet, no tools defined yet. The only thing I defined before is my workpiece. So my part to be cut and my blank material. So that's the only thing which I defined. And the first step I'm going to do to make this clear is that I'm going to search for geometry which NX recognize. So in this case, pocket slider, that's created as a custom feature to recognize. And I'm going to check steps here, and that are just the holes, blind or true holes, with thread, no threads. That's all the same. The holes recognized, that's out of the box stuff. The sliders which I'm selecting now, that's the custom stuff. Next step will be select it all, and I can create a feature process for this. And so not only the holes, which are best practice out of the box, but also in my operation set, there is a custom operations created based on the geometry, which is recognized. Now you can see if I go back to the operation navigator, so hold on, so to the operation navigator and to the geometry view, you see that there are 3 groups created, 3 feature groups, and some operations and some operation groups with some operations in there which I can generate directly. And this is a 3-step done in 3 steps, let's say. So after generation of these operations, I already have my toolpath available. So as you can see, it's coming up now. This will take, in my case, with the slider and all the holes, like spot drill, and tap, will take 30 seconds. And so it's a roughing operation in there. It's a finishing operation in there, and it's a spot drill for the M5 holes and a spot drill for the M6 holes, and drilling and tapping also. If you want to do a treadmill on different size holes, is also possible. I just defined this as a tapping thread. So this is how you get to the end result. So let me now show you that, well, of course, this will be a normal operations, but now I'm going to show you how to get there, how to get that automation. Now I'm going to show you here, this is my teach part. It's just in a different mold with some predefined operations in here. Also normal operations just created by NXCAM. Next step will be that I'm going to teach NXCAM to recognize this slider geometry. Yeah, so we have that the 3 levels, 2 open pockets and 1 closed pocket. I'm going to tell NX that he, from now on, will recognize geometry forms like this, even when the dimensions are different. I'm going to create a new feature type, give it a logical name. So pocket slider, I'm going to call this one. I need to define a recognition rule. I will use the same here. So let me use the same here. So give an enter. The pocket slider is done. And then the only thing what I have to do, and this is a one-time effort, I only have to select the geometry. So when I'm selecting all open and closed pockets here for this slider pocket, it will be stored in the database and ready for reuse, which I'm showing you in a second when I teach this recognition rule. So I'm going to hit the teach recognition rule, hit OK, and then it's stored in the database. Now, just for testing, I'm going to do find features again, as I did before on the other mold. And as you can see, when I check the pocket slider, recognize or find feature, and this will be a pocket slider 1. The number 1 means that this is the first feature of this kind. If you have 15, that probably will be 15 numbers. And so next step, I'm gonna create a group from that. And now I'm gonna create a group that is not really logical with one feature, but if you have multiple, there will be multiple features in this geometry group. Give it a logical name again, and that's what you have to do with automation anyway. Make logical names and use logical names just to know that you know what you're doing and what you're dealing with. Drag the operations in there. And then the second step in this automation, I'm going to teach NX to apply these to operations when this feature is found. So in the teach operation dialog, I can show you that all attributes available in the two different operations will be there. So that's a feature operation parameters and the tool parameters. So that this is all available for further customization. Joe will show you later in his session a bit of that, and of course some other attributes which are available for customization. Teach the machining rules and hit OK, and then the second part is also stored in the database. So the feature recognition is stored, the operations are stored. And that's basically what it is to automate this. Now, let me show you the same mold. I'm going to just change the color here. So you can see that it is a new test of this part. Just going to do this stuff again. I'm going to show you that it's the same part, but then with the part defined, blank defined. Going to find the features here. Select the pocket slider, select the steps. As I said, the steps, that's the out-of-the-box best practices content, which is already there for everybody who has NX installed. Select all found features, create a feature process, and then that's basically the 3 steps what you have to do. Find features, create your feature process, or create your geometry groups with the operations, and the last step in this will be just generate them. And that's also something all tools retrieved from the library. That's done automatically based on the rules you define. Then just generate all operations, and that's it's going to take 30 seconds, and I think it's 35 seconds, and then all your operations are done. And from now on, all slider pockets I'm going to create in future for any of the molds with this same geometry will be recognized. So roughing is done, finishing is done, and the spot drill of the M5, spot drill M6, drilling for M5, M6, and tapping for M5 and 6. And that's it, basically. That's all there is. So over to you, Joe. Thanks for the time you invest in this. And Joe is going to show you a bit more on the automation, including PMI. So thanks.
Sorry, guys, I was on mute there. So I hope you can all hear me. Good afternoon. As Pedro has already introduced me, my name's Joe Taylor, and I work for the UK team as part of the pre-sales for NX CAM and NX Additive. And I'm going to follow on from what Steph's just done a really nice job of introducing around feature-based machining, but with a focus on PMI, product manufacturer information, and how that is a driver and an influencer in the operations and tools that are selected when it comes to automatically creating operations against features. So first of all, I'd like to just quickly open up a sample part. This part, I'll share the link to all of the attendees later on. You can get hold of this as part of the feature-based machining kit. It comes with everything you need to get started. But as you can see, pretty generic style part. We've got some PMI on the components, some for surface finish. We've got a H7 limit of fit, some linear tolerances, and we're going to be talking a little bit more about this pocket a bit later on, this 40mm wide pocket with a plus 0.6 less nothing tolerance. But first of all, I want to show you a little bit about how we use PMI on products in NX CAM. So I'm going to create a new manufacturer setup. So that's entering the CAM part of the application for those not familiar with NX. And what I'm then going to do is create a clone of the design data, which we call a wavelink body in NX. And when we do that, we create an associative link, which allows us to work on a body which isn't the design part. So we've got freedom to work with the data. And as you can see, it also brings through the PMI. So we've now got an associative link to the design part for geometry and PMI. The next part of the workflow is to create the workpiece, which is basically specifying what we want to machine. So I can select the geometry in the window. And then we can do the same as what Steph did and start the feature-based machining steps, which is basically to, first of all, find the features. And for this first example, I'm just going to look at the holes, which we call steps in the feature library. And in particular, I'm only interested in two holes, sorry. One hole that doesn't have PMI directly associated with the size of the hole, and the other one which does. Okay. So when we go to our nice selection tool in NX, I can select the feature in the UI, and you can see that in our feature navigator, it displays the features for us. I can switch on the PMI toggle. We can see that there's a linear dimension against both, but this one also has a H7, a limit of fit tolerance. So that's a tolerance on the diameter of the hole. So if I create the feature process, first of all, for the hole that doesn't have the PMI, NX is going to look at the hole, it's going to look at the size of the hole, it's going to select a tool and appropriate operations to machine that hole. It's a 10 mil hole, so it's going to spot drill, which does two purposes, spots and creates a chamfer. The second operation is to drill the hole size. So it's selected a 10 mil drill and it's gone straight in with a drilling operation. Now let's have a look and see what happens when we apply the same rules to a hole that has a limit of fit tolerance. So again, we go through exactly the same steps. We don't have to select anything differently. We simply run the feature process creation. And this time you can see we have an extra operation that's been created. So the PMI and the tolerance has driven NX to output, again, a spot drill to drill a chamfer, again, a drilling operation, but this time it's selected a slightly smaller drill. And that's to leave some stock material into either ream or in this case, to bore the hole to size. So it's all about using PMI to drive the decisions that NX makes around which operation types it's going to use. So it's all very well on holes, but what about other features on parts? Very similar to what Steph just showed us with his slider. Let's have a look at this pocket. So the first thing I'm going to need to do to decide how we're going to machine it is to find the feature. So the same way that we went about it for the holes and the same way that Steph showed is simply searching for that feature type. In this case, it's a slot. I can disregard the other feature. I'm only interested in the one. And then the same as what Steph did, what we're going to do is create a feature group on this feature. The feature group allows us to then create the specific operations that we want to attribute to the feature, and as Steph did before, teach those back. So again, I'll just rename this something logical. I'm going to call this PMI slot because it's PMI on the slot, and that's the example. And I'm going to put R and F because I want to rough and finish this operation. If I was looking at this from a machinist point of view, plus 0.6 less nothing is quite a big tolerance. So I'm going to create a pocketing operation, and I'm going to finish that pocket in a single operation. So I don't want to leave any wall stock in. Just going to pick a tool out of the library. We've got quite an extensive out-of-the-box library, so I can just search for a 12 mil tool. Pick the first one off the top of the list just for this example. I can then go through the dialog, change some parameters. I'll make it a follow part, so it's cut in an open pocket, select a thickness, and I'm going to turn off cut compensation because, as I said, plus 0.6 minus nothing is an open tolerance. I'm very confident my machine can hit that limit very easily. So you can see in a couple of seconds, we've created the operation, I've simulated it and validated it in the display, and that's great. Now, what if that tolerance was a tighter tolerance? What if it was, plus or minus 0.5? So this time I'm going to copy that feature group, rename it to rough and finish with cutcom. Okay, I'm going to have to just reassociate the feature group with the feature. And then what I'm going to do is look at that first roughing operation. And this time I'm going to leave some stock because I want to break it into two operations. If I was machining this, I would want to run the finish path a couple of times to ensure that we get into size. So all I do is change the parameters in the roughing operation to leave 0.5 mil material on the walls. And then what I'm going to do again, a nice feature in NX is to copy and paste that operation, rename it as F for finishing, and I'm going to change some more parameters in this operation. So I'm going to turn the stop to 0. I want to finish the wall. I'll select a profile cut pattern because I only want to cut once, and I'll turn on the cutter compensation because I want that extra level of control from the machinist's point of view. And there we have it. I've now got one feature group for the feature to finish in one go, and I've got another feature group to finish the operation in a rough and a finished operation. Now what we have to do is very similar to what Steph just showed us, and that's to teach the operations. But this time I'm going to add some intelligence. I'm going to apply some logic. So again, using all the attributes that are available to us, I'm going to select the upper and lower length values. So in this case, it's a plus nothing plus 0.6, but it could be a plus or minus. So for that reason, I'm going to do the lower value times -1. So if it is a minus 0.2, that will make that a positive number. I'm then going to add that to the upper limit. So if it was -0.2 plus 0.2, that would give us a tolerance band of 0.4. And then I'm going to add a condition. So I'm going to say, if that value is greater than, say, 0.2 millimeters, I want to use this operation and this operation set that we've just created. So once I've taught that, I'll just copy this string to save time. Once I've taught that, that's now in the database. That's now in that feature library. So I can now go into my second feature group. Again, go into the teach operation sets. Again, you can see all the parameters for both operations and tools are all available. I can paste that string and simply flip the condition. So instead of greater than, I'll now make it less than or equal to. So anything with a tolerance band less than 0.2 will now apply the second rule, which is going to be roughing plus ½ mil and finishing with cutter compensation. And it's basically as simple as that. So let's test it. Let's clear these operations out that I've just created. Let's go back to the operation navigator, and this time the feature navigator, and this time we're going to create the feature processes. The same as what Steph showed, we can go down to our operation sets that we've just created, and you can see that under that slot partial rectangle, I've got those two feature groups and associated feature processes. And now in the next, you can see, yes, because the tolerance is greater than 0.2, it's created a single operation to rough and finish that cavity, that slot. So going back a step to the start of the process where I showed you that we have associativity with design, if I just jump back into the design part, say the designer has made a change, they've decided that there's a dowel or something that slides into this slot that needs tighter finish, we'll change the tolerance to a bilateral plus or minus 0.05. So they give us a tolerance band of 0.1. So now, if we go back into manufacturing, we can see the PMI has changed. We need to now go and validate that change by approving it, because obviously we need to be made aware there's a change. Yes, I want to accept those changes in the tolerance. And then we can delete that previous operation that we created automatically and recreate the feature process on that feature. And this time what you'll see will happen is it reads that tolerance value, and that value is now driving the operation selection, the tool selection out of the library to determine what sort of operation type we need to use. So now there you can see we've created the two operations. So it's all very well me showing you this on this test part, this teach part, sorry. But let's open up a component that's it's already a cam set up, and it's got a multitude of slots. Slots of different depths, widths, corner radiuses, and in this case, tolerances that have been applied to it in PMI. Because of the logic and intelligence behind feature-based machining, I've been able to add certain logic into the feature finder, which means that it will work out depth of cut, tools to be selected, depending on certain parameters from the features. So what you're about to see here is we select all those operations, create feature process, again, looking at the same rules that we just created, and we will almost instantly, very quickly, create a full set of operations for these slots. Okay, there we go. So as you would expect, 4 of them have got a tolerance of plus or minus 0.25, a tolerance band of ½ mil. 2 of them have got a plus or minus 0.05, so 50 microns, so that's a tolerance band of 0.1. So 2 of them fall within the category of requiring what I would expect to be a roughing and a finishing operation, and all the rest are finished in one go. Okay, so there again you can see an example of the depth of cuts and the difference in the size of the features, but we've still been able to automatically create the operations to cut these features. Okay. So I suppose the final thing to show before I close is, again, let's make a change. So let's just prove that by updating the tolerance on that 25 mil slot, again, jumping into the design part, we'll automatically update the feature processes that are selected, that are driven by the PMI. So let's make this plus or minus 0.1. Let's put it right on the threshold of that rule of less than or equal to 0.2, and rerun the feature finding. So again, we have to approve the changes, and then we will delete out the now out of date operation, and we will create a new feature process on that feature. And that's it. Fantastic. We've now created that rough and finished operation. So quite a simplistic example, but a nice example of showing how PMI can do more than just, add a reamer in. We can actually define what sort of operation process is going to be used on the shop floor, whether it's going to be 2 operations, 3 operations, whether it's going to be a helical mill, or whether we can drill and ream. There's a lot of logic and power that we can apply in feature-based machining. And as I said before, we've got the feature-based machining kit, which is available to anybody. Obviously, you need an X to use it, but that's we can get around that as well with the new cloud trial that we can do for NXCAM. So if there's any questions on what you've seen, please put them in the chat, and we'll pick them up at the end. Thank you very much.
Thank you, Joe. So I would need now control. So if you can, you tell me if you can see my screen, please?
Yes, we got it. Yeah.
Okay, so just to finalize, and again, thanks, Joe and Steph, for your presentations. I'd just like to summarize the fact that programming automation within NX will deliver important reductions in programming times. It will deliver programming efficiency through the capture and reuse of proven machining methods. Also, it allows for faster, repeatable, and consistent NC programming, but at the same time, and that was clearly shown by both Steph and Joe, flexible with the arguments of feature teaching that both of you, Joe and Steph, shown. Also, users can apply changes or influence the automated programming. So you're not fixed to what the software will deliver. You can still influence the final results. And last but not least, it delivers part manufacturing consistency and quality. So we now are open for a few questions. You can either use the chat box, as Joe has mentioned, or use your microphone. We're more than fine with that. So
we've got a question in the Q&A about, do your tools need to be defined prior to using feature-based to identify the operations? So feature-based machining, you can put in the parameters, as you just saw, with regards to driving PMI, and it's very similar for the tools. So some simple logic would be to pick maybe the corner radius as an attribute from the pocket, and say the tool must be, the radius of the tool must be less than the radius of the corner of the pocket. And then what NX will do is say, okay, I know what that rule is. It will filter out all the tools from the library that match that criteria, and then find the one that best suits the other attributes. So tool selection can be automated dependent on the size and the depth of the feature that you want to machine, or you can then go ahead and maybe assign a specific tool to a specific feature if you wanted to lock in either 1 or 2 or 3 tools that you wanted to use. So there's a lot of flexibility, and at the same time, it's about not just being able to use feature-based machining to automate, but also to capture and reuse the knowledge from within your company. Any particular tools or features, we can capture those and reuse them again. Another question, how can rule set use be captured for part traceability? So I suppose that goes back to what I just said about the being able to capture and reuse, that these rules go into a library. So there could be somebody who is responsible for managing and approving these rules that would want to be rolled out throughout the company. That's just simply a write access functionality. And as for traceability, yeah, that would just be making sure that you're managing the data from the database. That's a good question on MRL. Steph, do you have an answer on pulling tools for MRL for feature-based machining?
I don't have that question Joe.
Okay, sorry. In the Q&A, there's a question. It says, will it pull tooling from the MRL as well?
Yeah, if you define the MRL as your tool database, yes.
Absolutely.
Yeah, that's just in the definition of your configuration.
Was there any other questions?
And the second question you answered, Joe, on the tooling, or I think it was your first question. Do your tools need to be defined prior to using a feature-based to identify operations? Yes, you need. I'm not sure if it was answered by you completely, Joe, but you need to define your tool database before, or else NX cannot find tools. If you cannot find tools, you cannot map any operation to the feature you find.
Yeah, that's yeah, you're absolutely right there, Steph. Yeah, I was thinking more just using the out of the box tools and how you would define them, but no, you're right, from a tooling library.
Yeah. So if you want to use your own tooling, you would need to define it before. Feature-based machining will not create tools for you because it's impossible. He can create any tool in any radius, in any diameter, and any length, and that's not what you want probably.
Okay.
So let's just finalize now. I mean, of course, we can be available if you have any further questions. But would like to share with you a list of the upcoming webinar topics that we'll be covering. So you can see on the right-hand side, we'll be addressing multi-channel, multi-turning programming, the true digital twin of the machine tool, features and devices management, 3D tool graphics creation, custom operations creation, and work instructions. So look out for your next invite. And we would also like to please complete the online feedback. You can scan the QR on the right-hand side, or after this event, we'll be mailing all the people that attended with this link that you see at the bottom. It only takes a few seconds to complete. It's important. It also gives you the opportunity to influence maybe other topics you'd like us to focus in forthcoming webinar sessions. So that's more or less it. Here you have our contacts. By all means, do get in touch with us if you want to discuss today's topic further or any other topics related to NXCAM. Thanks again for your time. And again, look out for the next session invite, and have a good rest of day and week. And as you've surely have not heard before, stay well. Thank you very much.